एवरेज 19 था फिर
Hi, this is Sarath. Along with our teammates Karthik and Sri Lakshmi, we are here to demonstrate on our MPMC project Obstacle Avoiding Robot. So, in this growing era of technology, autonomous vehicles and robots has its high phase. So, what the key feature of those robots and autonomous vehicles are to move without clashing. So, obstacle avoiding is a key feature for those things. And here we have brought a solution by using a microprocessor based robot. It uses ultrasonic sensors to detect the obstacle and avoid them. So our project demonstrates on avoiding the obstacles and moving without clashing on objects.
So, hello, my name is Karthik Krishna, and I'm a member in this project that created the obstacle avoidance server. So, basically, what we did was create a autonomous kind of a device that will move through a course, or it will move through a route, and in case it detects an obstacle, it will look on the both sides, its left and right distances, and compare those distances, and turn towards the side which has less obstacle or has more distance based on the data it got from the ultrasonic sensor. So it actually consists of a Arduino Uno, an L298 motor bridge driver, a servo to turn the HCSR04 ultrasonic sensor, and the sensor itself. So I'll start by explaining what the L2910 thing is. So L2910 is a popular kind of motor driver module that's used in many IT applications, basically to control the speed and the direction of the L2 or direction of the motors that are attached to it. It's called a dual speed driver because it can control two motor drivers or two motors simultaneously with the help of the input pins IN1, 2, 3, 4 it receives from Arduino or any microcontroller. So and its voltage range is typically from 0 to 35 volt, but in this we are supplying it with 5 volts that taken from the Arduino's 5 volt pin, and then additionally 12 volt that's we are supplying it with. And and how it works is that the alternating driver allows you to control the speed and direction of the motors by changing the control pins. The control pins are IN1, IN2, IN3, and IN4, like you can see here. So to move a motor forward, the IN1 and IN2 pins are dedicated for the motor A, and IN3 and IN4 pins are dedicated for the motor B. So in order to move a motor forward, you can set the control input high and other part low. Suppose if I set the IN1 high and IN2 low, it will move in a forward direction. Similarly, if I change the IN1 to low, IN2 to high, it will move in the reverse direction. In this way, based on the PWM inputs it receives on the Arduino, we can change the direction as well as the speed of the motor that's attached to this driver. And the speed can also be controlled using the enable pins, but basically in this project we have the enable pins ENA A and ENB are already shorted together. So coming to the next thing, I mean, we already used this module to for the functions like move forward, move backwards, move, turn right, turn left, all these functions. And now coming to the Arduino Uno. Arduino Uno is a popular microcontroller board in the Arduino family. It's based on the Atmega 328P, and it's usually used for such hobby kits and all other projects, which has a sub operating voltage of 5 volt, and it has I think a total of 14 pins, out of which 6 are digital or used for PWM generation. And coming to the HCSR04, before that, in this code, what you've done is that in the Arduino INO file, the setup file consists of the things like we have defined the output pins, like the output pins for the motor driver and the output pin for the HCSR04 driver, and also the servo, because we have to turn the servo between 0 to 180 degrees. And I think Sri Lakshmi would have explained all of that. And now coming to the SCSR04, SCSR04 is an ultrasonic distance sensor that is commonly used in robotics and other applications to measure the distance between the rover or the object and an obstacle. It works by emitting an ultrasonic signal with this eye-like thing on it. These are actually ultrasonic transmitters. At the same time, they can also detect the reflected back signals. Once it emits ultrasonic pulse, it measures the time it takes for the echo that was sent to return back, and then it basically gets a trigger signal. And this trigger signal is sent back to the Arduino, and within this time, by measuring to measure the distance, we can use the speed of the sound wave that traveled and came back to get an almost an accurate measure of how long the obstacle was from the rover, and use this to feed into the loop function in the Arduino. The loop function has things like the distance that was taken from the CSR04 and all, and use that to determine whether it should move forward or turn or pause or move backward, turn left or right, and find the distance and all. So that's all from my part. Anyway, thank you.
Hello, so now I'll be explaining the code for an obstacle avoiding robot. Here we have used an Arduino, a servo motor and an ultrasonic sensor. The robot moves forward until it detects an obstacle within a certain distance. Now based on the distance measured on either side, it decides whether to turn left or right, and hence it avoids the obstacle. Now here we've used two libraries, the servomotor-h and neopeng.h. The servo.h, it is the standard library that is used to control the servo motor. It helps in scanning the environment by moving the sensor to look left or right, and the neopeng.h library manages the ultrasonic sensor, which measures the distance to obstacles in the robot's path. Then we have the pin definitions here. We have 4 pin definitions: left motor forward, which is pin 7, left motor backward, which is pin 6, right motor forward, which is pin 4, and right motor backward, which is pin 5. These are all for motor control. And for the ultrasonic sensor, we have trig pin, which is analog pin A1, and echo pin is analog pin A2. These are for the ultrasonic sensors. Then we have a constant defined here, which is the maximum distance. Maximum distance is set to 200 centimeter, and it represents the maximum distance the ultrasonic sensor can measure. Then we have variables defined, which is distance. Distance stores the distance measured by the ultrasonic sensor. Goes forward is a Boolean variable that keeps track of whether the robot is moving forward. And right distance and left distance, these variables store the distances measured to the left and right side separately. Then now coming to the setup function, this function initializes the robot. Here motor control, the motor control pins are configured as outputs, and the servo motor is attached to pin 10 and positioned at 115 degrees to set its natural scanning position. And distance calibration, the initial measurements are taken multiple times to ensure the ultrasonic sensor is ready and accurate before the main loop starts. Now the main loop starts here. So the main loop function controls the robot's movement and behavior. Here the distance measurement is like the robot continuously measures the distance to obstacles using the ultrasonic sensor and stores result in distance, which is the variable. And obstacle detection is done using, so here is where the obstacle detection part is done. If the distance is less than 20 centimeter or less, the robot stops, moves backward for a short period, and then stops again. If it then measures the distances to the right and left using the look right function and look left functions. Now the robot decides to turn in the direction with more space available. Now if no obstacle is detected, the robot continues to move forward, which happens over here. Now then coming to the helper functions, which is we have two helper functions, look right and look left. These functions turn the servo motor to the right or left. It measures the distance and then returns the value. Then we have the movement functions, which is move stop. Move stop stops the robot by setting all motor control pins to low. Move forward moves the robot forward by activating the forward motor control pins. And then move backward moves the robot backward by activating the backward motor control pins. And turn right turns the robot to the right by adjusting the motor control pins appropriately. And the turn left turns the robot to the left in a similar manner. So this was our code. So this program basically enables our obstacle avoidance robot to use a servo motor and ultrasonic sensor to scan its surroundings. It then stops and evaluates the environment whenever an obstacle is detected, and it decides whether to turn left or right based on the available space. And then it resumes forward motion after avoiding obstacles. So this was the code for our obstacle avoidance robot.
So next, let's speak about the future works, like how we can improve this project. So we can add some additional sensors to improvise the quality of quality. Like we can use an infrared sensor in supplement to the ultrasonic sensor which we are using now. We can also use some path calculating algorithms like Digitstars to calculate the path efficiently and utilize it accordingly. So we can also integrate an wireless communication mode like Wi-Fi or Bluetooth through which we can connect to our mobiles and command the system accordingly. So next, let's go to the application. As I told, it has wide range of application in automobile industries and also in space research. So nowadays we also have some. It is also getting into the household appliances. Like we have a cleaning robot which use an obstacle avoiding technology. So it can also be used in medicals and all other industries, and the research is still continuing in that. So thank you.